Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We're going to have a little bit of goofing around electronic fun here. I just did a video talking about electronic reference videos, and I decided I was going to mess around with some of the experiments in this Make Electronics book that just covers some basic electronics, and I'm going to use this ProTech Trader kit that goes with this book. It covers experiment 1 through 11. And it's got everything I need in here. It's double-sided. It's got everything. So I've held on to this. I haven't used the components it came with. I've used my own components. But I think I'm going to go ahead and use the components it came with this time and see what we get. So let us take a look here at what we got. So let's just kind of look at the experiments, and I'll explain them in my own way. So we're not touching a 9-volt battery to my tongue. I won't do that. But we can read the voltage of a 9-volt battery. Let me grab a 9-volt battery here. I have a 9-volt battery, and we will take that down and put the meter up there. And we will grab our probes and knock things down. So we're measuring volts DC on that, and I need to actually show you that, so let's do that. There we go. So I'm going to take this and I'm going to hook this up to the positive, and then I'm going to hook this up to the negative, and I am in diode mode. Oh, come on, seriously. Now I have to... just stop it. Get out of remote. Volts DC. Okay, now I can go back into remote. I'm still getting used to this software, guys. Okay, now we're in DC voltage. So I'm going to put this on the positive, this on the negative, and I should get about 9.2 volts, so it's a good cell. You know, 9.2 volts, 3 volts. So there's our DC voltage. It's on an auto 60 volt scale. So we have our voltage. We used our meter to test it. Experiment done. Okay, let's find experiment 2 here. Yeah, I'm not going to blow a fuse up. I've already did a video on blowing fuses. Okay, so here we go. We got a light and LED with a 9-volt battery. So it says make sure you have a fresh 9-volt battery. Use the battery connector. Just clip a couple test leads. Select a 2.2K resistor. So let's open up the kit. I believe resistors are on the back here. So we're going to find a 2.2K. 2.2K ohms is right there. It's a tiny little quarter-watt resistor. I believe that may be 1/8 watt. That looks like 1/8 watt resistor. Doesn't look like quarter watt, you know. So I got a 2.2K resistor here. So I need that. Let's just check the color code. That is red, red, red. And red is 2, 2, and 2 zeros. So 2.2K. 2,200 ohms. So we needed that. Let's just look at what we need on the page back here. Okay, we need a 2.2K, a 470, and a 1K. Okay, here is a 1K. And a 1K should be brown, black, red, I believe. Brown, black, red, 1K. Okay, and then we need a 470. 4.7. We got a 470 here. And we're going to hook it up just like they tell us to hook it up, because we're going to be crazy following the book. And this one is yellow, purple, brown, and yellow is 4. Purple is 7, or they call it violet on my card. 4, 7, and then brown is 10470. So we have that. Is it all checks out. You don't always trust what it's labeled. And then we need a generic LED. And we're going to do some extra tests with this about current draw and stuff, just so I can teach you guys some more about basic electronics. So I'll close that side up, and then we're going to get the alligator test clips out, and we're going to do some craziness here. So I don't even have a battery terminal, so we're going to get these test clips out of here. So we got the test clips and the battery, and we got a meter. So let us follow this here. So we're going to hook up the battery last. So we're going to take our red is going to go to the positive, and the positive is the anode. And now in the time of Corona, I say Anne has Corona and Cat doesn't, is negative for Corona. So anode is positive, cathode is negative. So we're going to connect, we're going to splay these out a little bit so our connections don't touch. So we're going to connect the long lead of the red, and then we're going to use the 2.2K, so the all red resistor. And then we're going to go with the green one here, and then we'll hook it up the way they say, and then we'll do some testing on it. So we got this one. This is definitely not the way you do this, guys. I'm just going to let you know right now. But, you know, we're learning. This set of components is super cheap. So we got the positive. Let's hook up the negative first. I'm not even going to do the positive. I'm just going to touch it here. So here is our rat's nest all in the shot. So I got my LED and my LED lights. Doesn't light very brightly. So what I want to do is I want to find out how much current that is drawing. Okay. So what I'm going to do is I'm going to take my thing out of remote. Take my thing out of remote, and I'm going to plug in my meter to amps. And I'm going to select amps. And then I'm going to display my amperage. Change my clips out. So now we have amps showing here, and I am going to replace this red clip here. Let me just go out a little bit so you can see what I'm doing. I want to see what the current is through the circuit, so I'm going to replace this positive lead here with the positive side of my meter, and then I'm going to put my probe on the other side so I can touch this battery and we can see what the current is. Make sure I'm on current. Make sure that I am plugged into the right port. I am. It is reading current, and let's do this. So why am I reading a negative? Oh yeah, I hooked that up wrong. That was my bad, guys. See, if you don't pay attention, you mess up. I totally read that wrong. But hell, it read a negative current, so that's good. So now we're going to do this correctly. So with the 2.2K resistor, we are reading roughly 2 milliamps. You guys can see that on the screen. So roughly 2 milliamps with the 2.2K resistor. So that shows that the 2.2K resistor there is dropping the current to 2 milliamps. Now let us bring in some cheapy meters, because I only have one good benchtop meter, but we're going to zoom out for this because we're going to bring in some cheapy meters to do some cool stuff, because I want to show you something. So we're going to come in here and we're going to go to the voltage range. Go to the 20 volt range. We're going to put that meter there so you can see it, and we're going to clip across the resistor. No, I don't want to do that. I want to clip across the diode with this one. The diode, I want to see the voltage drop across the diode. So there's the voltage drop across the diode. And then now I'm going to grab my other cheapy meter, because they have the alligator clips on it. And an alarm is about to go off, and I'm sorry about that. So we're going to do 20 volts on that one, and we're going to put this across this resistor. And hope all these are connected correctly. Okay, so I have current being measured in the top corner of the screen. I have the voltage across the diode here. I have the voltage across the diode here, voltage across the resistor here. Now, I would say that the voltage drop of the diode is going to be in the 2 volt range, and the rest is going to be dropped across that resistor. So let's find out. So we're still drawing 2 milliamps. The diode is dropping 1.9 volts, and the resistor is dropping 4.28 volts. So if we add, so say 5, 6. So we're really only getting 6.5 volts coming from all this. That means the wires have resistance and they're dropping some voltage. So yeah, because we don't add up to 9 volts. Volts in is supposed to equal volts out, and we don't really have that on our drops, so there must be drops across the wires. Could be these cheapo meters. Who knows? So now, if I was to check the current anywhere other in the circuit, it would still be the 2 milliamps. So there's that alarm. So it would still be the 2 milliamps. So now we are going to change that resistor, and we're going to see what happens. We're going to leave. We're going to leave these set up so you can see that this is. I'm going to reverse these. So this is next to where the diode is, and this is down here by the resistor. This is just insane to build a circuit like this with all this wiring. So I'm going to come in here and I'm going to change this resistor. So I'm going to put the 1K in, which is it 1K? 2.2, 1K resistor. So 1K is going to be brown, black, red. So connect it to the circuit, and connect it to the circuit, and we'll connect it to the meter for the voltage drop. And we'll check the current flowing through this circuit with the lower resistance. Now, in theory, it should be more current, and the LED should get a little bit brighter. So the LED is a little bit brighter. We're now dropping still 1.9 over the LED. We're only dropping 3 volts on the resistor, which makes even less sense. And we're drawing 3.4 milliamps, so another milliamp and a half, 1.5 more milliamps. And you can see that the LED is definitely brighter, so you can drive these with higher resistance loads. It does lower the amperage range pretty low. So now we're going to do the 470, and you'll see that it, first I'm going to mutilate my resistor. Okay, so now we're going to do the 470, which is orange, purple, brown for a 7 and 1 0. Alright. Okay, so now we have that hooked up, and this should draw more current. And it is going to draw 5 milliamps. So, draws a little bit more milliamps. It's definitely a lot brighter. What I'm going to do is I'm going to pull these meters off. These voltage drop meters here. And see if that affects the brightness of the LED. Okay, so let's. That LED was getting hot. Okay, so we gotta hook this back up to the negative, and we'll see what the LED does without the meters in line. So it's still 5 milliamps. Now, I wonder if the shunt resistor on this meter is lowering that, because I wonder if I just hook it up directly if it's any brighter. So let's see if it's any brighter without the meter in line with it. So it looks a little brighter without the meter in line, so let's try a super crappy meter and see what we get on this one. Let's put this on to 20 milliamps. And let's hook the cheapy meter in there for amperage. This is why I like these meters, because you can abuse them, say. No, it's still 5 milliamps. So, alright, so that is that experiment. You could see how the current, the resistors limited the current through the LED. And, you know, right there we learned properties of a resistor. We learned what a forward voltage of a diode is. And we learned how to hook up multiple meters to measure things and get a mess of cords everywhere on your bench that is going to take hours to organize and put away. And I want to go back off of my meter for a second and go back to this. And I want to plug back into voltage. And I want to go to DC voltage. Okay, so I want to show you my meter again. I'm getting better at this, guys. This is the first day I've used the meter as a test instrument on camera. So we're going to test this voltage again and see how much it dropped. So it was 9.2, it's 8.97. Yeah, you can see that, guys. Good. So, oh, it's 9 volts. Alright, so, and I could have used my power supply to simulate a 9-volt battery, but we did it the way it is because you can use a 9-volt battery. So, and if you don't know how to read the color code, let's talk about reading a resistor with a meter. So I can do this here. We will show you the output on the meter on the screen. Okay, I definitely know how to do this. Okay, now let's play that. Is that gonna work? There we go. So I got resistance, 2-wire resistance. I'm not going to go into the difference between 2 and 4-wire resistance right now. So now let me show you. I will demonstrate on this meter here. This is a mid-range meter. It is good, but the screen is horrible for the camera. So if I wanted to test ohms, I would go over here to this ohm signal right there, and then I could test ohms. So this is auto ranging for ohms. Also on this little cheapy meter, there is a ohm section in blue here. Let's zoom down. These are the best meters to start off with, especially if you're doing electronics. This is a great meter to start off with. They're like $3. You could even buy like 6 packs for like less than $20. And I mainly use them for measuring current, because if you blow it up, who cares? It's $3. You have ohms, 200 ohms, 1000 ohms, 20K. So this one you have to get in the ballpark, an auto ranging meter like this, or this right here. This is auto ranging. You just put it on ohms and measure it. So you put it right here on ohms. So that is that. I will demonstrate on this little meter here real quick, just so you understand. So say I don't know the resistance, so I'm going to come in here, and I'm probably not measuring anything too big, so I'll go to 20K, and I'll just pick up one of these random resistors. Polarity doesn't matter, and I will clip these on. And it's showing like 0.97, well, in the 20K range, so I can click it down a level, and I'm showing 974 ohms. So let's check it with the bench meter and see if it's worth having. So 0.973. So the bench meter measured the same thing as the cheap $3 meter. So there you go. You know, I could check it with a 4-wire resistance and it would give me a more accurate reading, but come on, we're just doing basic electronics here. So I measured that one and I found out that was roughly 1K. It's within its tolerance. So now I have this red. Well, heck, what is red? Let's plug it in here and see what happens. I'm going to leave it on the 2000 range, but we're going to see what happens. Nothing happens. It's like, oh man, I got a 1 on here. What is going on? Let me just click it up a range here. Oh, okay, it's because my resistor is bigger than 2000 ohms. So this is 2.15. So, okay, so it's a 2.2K, 2.15. Let's measure it with the meter on the screen. And 2.15. So again, same accuracy, guys. $400 meter, $3 meter, same accuracy. Let's check this last one. I don't even remember what this one was. So we're gonna plug it in here on the 220K range. I'm getting like 4.47. Oh wait, I'm on the K range. Let's go down to this range. This looks like 472 ohms. So this is the 470 ohm resistor. That's pretty close, 472. And let's check it on this one just so we can prove that my meter's not worth the money. Okay, so 470. This is like spot on. Wow, this is like well within tolerance. So, alright, so we've learned the value of resistors. If you are unsure about which way a diode goes, which is positive and which is negative, I'll show you on the cheapy meter here. You go to this diode function and just say, I'll hook it up backwards on purpose. And nothing happens. It doesn't show anything on the screen. But if I flip it back to the correct way, the diode faintly lights. You can kind of see the glow in the camera. faintly see the glow in the camera. See, I'll take it off. Goes away. Faintly see the glow. And then you can see I'm reading okay. I should be reading a forward voltage here. Okay, this won't read the forward voltage. But let me show you, because I wasn't planning on doing this part, but let me go back to local. Let me go to shift diode, and let me show you what it's supposed to do on here. So if I hook it up backwards, if I hook up the positive to the negative, it will show an open circuit. Open circuit, it's not lighting. But if I go negative to negative and positive to positive, it beeps showing me it's a good diode, and it shows me the forward voltage of 1.8 volts. And when we measured the voltage across that, it was about 1.8 volts, 1.9 volts. So that's how you check a diode. That diode was good. It doesn't really light it up, it just tells you what the forward voltage is. It could have lit it up real gently there. So there we go. We learned something from this book. The main thing is we learned to turn off our meters, because that is a thing. So we learned how to test the value of a resistor with a meter. We hooked up a little circuit, and then now we can look at a potentiometer. I will go over potentiometers in the next video. So I'm going to call it here, guys. This is about 26 minutes, so a little longer than I wanted. So thank you for watching, guys. Here's the links to social media. If you'd like to support me on Patreon, that would be great. I can get more of this stuff out. Maybe get some other learning books and kits and try to teach you some stuff from that. See if you like that format or not.